go ahead and take a look at the warm-up in your packet. And before you start exploring, I want to make sure you understand what is even going on here. So we have binomials that are raised to various powers. And so how do we get what's on the right-hand side of the equal sign? Well, we have to expand what's on the left. So for example, this one, a plus b quantity squared, that's a plus b times a plus b. So you do your double distributing. And when you combine your like terms, you have this. Okay, and so if you think about what it would take to do a plus b quantity cubed, you'd have to take this, what you just found for a plus b quantity squared, multiply that also by a plus b. So you'd have to take this and multiply it by another a plus b, which means, let me write that out, you'd be doing this. So here's what we had for right here. Now we're having to multiply it by another a plus b to get a plus b cubed. And so you'd be doing all this business, triple distribution, to end up with this. So as you can see, it starts to get tedious very quickly. And so today's lesson is about the patterns that we can notice and then a theorem that we can use to be able to hammer this right-hand side out without having to do all the distributing. Because you can imagine it would get really cumbersome by this point. So go ahead and observe the patterns, and then we'll proceed with the practice problems. So you should have noticed that the exponents on a are decreasing. You know, right here, this is a squared, this is a to the 1, this is technically a to the 0 right here. Here it's a cubed, and then a squared, and then a to the 1, a to the 0. You know, it always starts with the same number that you're raising the binomial to a power of. And then it descends all the way down to a to the 0. Now what's happening for the exponents on b? Kind of the opposite. Those are ascending, starting with b to the 0, and then you have b to the 1, b squared. Same here, b to the 0, b to the 1, b squared, b cubed. So that's the pattern on the exponents. And then the sum of the exponents on the variables on each term, if you notice, let's look at this last line. Obviously, there's just one exponent there. Well, we could even write in the b to the 0. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. So the sum of those exponents is always this power. So in summary, this PowerPoint is online. So looking back again at the warm-up, the patterns that we observe on the exponents, that just addresses the exponent. How do we know what coefficient is in front of each term? How do we know that that's a 4 and that's a 6 and that's a 4 without having to do it the long way? Well, that's what the rest of the lesson is about. There's a theorem for that. And it is called the binomial theorem once we get to it. But first, you need to understand what a binomial coefficient is. So this is read as n above r. And n above r is equal to n factorial over r factorial times the quantity n minus r factorial. So I'll let you pause that and write that down. Looking at example 1a and 1b, we're just going to practice finding n above r. And you're just plugging directly into that formula. So for 1a, 6 above 3, we're going to have 6 factorial in the numerator and 3 factorial times 6 minus 3 factorial in the denominator. And then you just simplify that out and get a value. Same here. Keep in mind that 0 factorial is 1. That comes into play on 1b. And so this ultimately equals 1. And so try your pencil problems. be sure to show your work on 1A and 1B. The next pencil problems, 1C and 1D, we can practice using the calculator. But show the work as was shown in the typed problem for this one. Okay, so for 1C and 1D, I'm going to take this opportunity to show you how you can do this in the calculator. It's going to be math, arrow over to probability, and it's number 3. And I know that seems random to you right now that it says NCR, but that's because, well, you'll learn that later in this chapter, why it says that. But just know for now that that is how you do N above R in the calculator, is this NCR thing. And so you hit that. So we're going to do 8 above 2 is 28. And then remember that if you don't want to have to go through those keystrokes again, you just highlight what you did up here and press enter and it copies it. And now we can type in, this is 1D now that we're doing, and get 1. So try your pencil problems, and you can just use the calculator, so I wouldn't expect to see work on the next two. So you should have gotten 49.50 for 1C and 1 for 1D. So here's the binomial theorem. So go ahead and pause and write this down. And, okay, so now hopefully you've written it down. And I'm going to explain what this is that you're looking at. This is the key to being able to figure out the coefficients of each thing. Now this a to the n and a to the n minus 1 and all that, that's what we discovered in the warm-up. We learned that whatever this power is, that's what the a power starts with, and then it starts going down by 1 each time. And the b power starts as being b to the 0, and then it goes up b to the 1, b squared, b cubed, all the way to until it's b to the n, whatever that was. So that part we already figured out from the warm-up. The new thing about this binomial theorem is the n above 0 gives you this coefficient. So like if we're doing this to the 5th power, this would be 5 above 0, 5 above 1, 5 above 2, so on and so forth until you get to 5 above 5. And I'm going to allow you to calculate that in the calculator when you're doing these problems. And then finally here, this is just kind of a summary of what this is explaining, because we're adding things up here, so you can write it using summation notation in a general form like that. So looking at example 2a, this is the printed problem, we're asked to expand x plus 1 all raised to the 4th. And so first of all, let's use what we learned in the warm-up about the patterns with the exponents. And x is going to start with a power of 4, and then it's going to go down until it's power of 0, and then the 1 is going to start with the power of 0 and go up until it's a power of 4. So x is like our a, and 1 is like our b, if you're trying to match it up with what we did in the warm-up. So I'm leaving space here for the coefficients, because we're going to use the binomial coefficient, or the binomial theorem, to fill those in. But see how so far I've just laid out the exponents, with the x's going in descending order with their powers and the 1's going up in their power. Okay, so in order to figure out what these coefficients are, since it's raised to the 4th power, that means we start with 4 above 0, then this one's going to be 4 above 1, 4 above 2, 4 above 3, 4 above 4. And then I am fine with you using the calculator to calculate those. And so again, the way you do that is math, probability, number 3. So 4 above 0 is 1. And so each of those creates the coefficient that you're going to have. And that is the answer. That's that. So try your pencil problem. actually think, yeah, I want to do this pencil problem with you.